Let's be honest, if you search Data Engineer Roadmap in 2026, you don't get clarity. You get a list of 50 tools and anxiety for free. One roadmap says Spark, another says Snowflake, another says Databricks, and then someone adds AI, agents, vector databases, data mesh, lakehouse, and suddenly you're not learning data engineering. You're collecting buzzwords like Pokemon. Hello everyone, this is Pranit and welcome to Big Data Factory. So in this video, I'm going to give you a realistic data engineer roadmap for 2026, what to learn, what to skip, and how to become job ready without drowning in tools. By the end of this video, you will know the core skills that still get you hired, the upgrades that matter more in 2026, three tracks you can pick so you don't waste months, where Databricks fits clearly, how AI changes expectations without turning you into an ML engineer, and a simple 0 to 6 month plan you can actually follow. Here is the big truth: data engineering is not Spark, not Snowflake, and not Databricks. Data engineering is one job: ingest data, transform it correctly, deliver it reliably, keep it fast and cost aware, and keep it trustworthy over time. Tools change every year, but fundamentals pay you salary every year. If you build fundamentals, you can switch tools in weeks instead of restarting your learning every time the industry changes its top 10 stacks list. To make this simple, think in four layers. Layer 1 is foundation: SQL, data modeling, programming basics. Layer 2 is distributed and cloud: Spark and cloud storage or compute. Layer 3 is lakehouse and data management, table formats and governance. Databricks often fits here. Layer 4 is production skills: orchestration, testing, observability, and a basic engineering mindset. If your roadmap doesn't include production skills, it's not a roadmap, it's a tutorial playlist. Another reason most people feel lost is because they assume all data engineer roles are the same. They are not. So in 2026, pick one track for 3 to 6 months so you can build momentum. Track A is analytics or warehouse data engineer. Generally, it's SQL heavy, transformation heavy. It focuses on clean data sets for BI and reporting. Track B is lakehouse or platform data engineer. Often, Databricks heavy, Spark pipelines, Delta or iceberg concepts, governance, scale, performance, reliability. And track C is streaming or real time data engineering. It focuses on Kafka, streaming processing, late data, SLS, and monitoring. You can absolutely switch tracks later, but focus wins early. Pick one track now, build one strong project in that direction, then expand. So we jump back to the layers which we discussed initially. Let's start with layer 1, foundation, because this is what gets you hired and what most people understand. First, SQL, and I mean advanced SQL, not basic select star. In interviews and real work, you need joins that don't break logic: Windows functions, deduplication, incremental logic, and performance reasoning. Second, data modeling. Understand grain, fact versus dimension tables, how metrics are built, and why bad modeling creates bad pipelines and confusing dashboards. Third, programming basics. Python is the most common, and Scala helps if you are Spark heavy. But the key is writing clean transformations, reusable functions, and basic error handling. Fourth, Git and Linux basics. Because real pipelines live in repos and run on systems, not just in a notebook tab. If you master this layer, you immediately become more employable because you will be one of the few people who can explain and implement logic cleanly instead of just making something run. Now, layer 2 is distributed and cloud. And this is where 2026 separates I know Spark syntax from I can solve real problems. In 2026, the value of Spark is not memorizing APIs, the value is performance thinking. If you learn Spark concepts like partitions, shuffle, joins, parallelism, joins and skew, and learn how to reason about these and how to debug them in Spark UI, and you will sound like someone who has actually operated pipelines in production. Alongside Spark, pick one cloud: AWS or Azure or GCP. Not all three, just one. Learn object storage, basic IAM permissions, and the habit of cost awareness. The difference between a junior and a strong mid-level data engineer is often not knows more tools, it knows what will break, what will be slow, and what will cost money. If you build that habit early, your growth becomes much faster. Now, layer 3 is where Databricks fits. And this is important because in 2026, many companies describe their stack as Databricks plus Lakehouse. If your target roles mention Databricks, don't treat it like a random new tool. You have to master end to end. Use a clean learning stack. First, Spark and SQL and Databricks. Spark's fundamentals still matter. You're just running them on a managed platform. Second, Delta Lake concepts. Think of this as a reliability layer that helps you avoid a data lake that is just random bucket files everywhere. Learn how reliable tables work, how schema evolution is handled, and why compaction and table maintenance matter. Third, Unity Catalog concepts, governance, permissions, control access, and why this matters even more when AI and more downstream consumers touch your data. Fourth, orchestration in Databricks. Understand how jobs and workflows run, scheduling, dependencies, retries, and failure handling. And one more mindset in 2026, don't become a tool fanboy. Understand the concept of table formats and governance so you can be portable across stacks, whether the company lanes Delta Iceberg or a mix across different regions. Layer 4 is production skills. And honestly, this is where careers are built. Most failures are not Spark syntax failures, they are production failures. Pipelines fail on reruns, backfills break, upstream schemas change, data quality issues slip in, cost spike, and nobody knows until business asks why numbers change. In 2026, you need an orchestration mindset, whether it's Airflow or platform jobs. Understand retrace versus backfills and understand idempotency, meaning reruns should be safe and predictable. You need basic data quality checks, not fancy, just consistent checks that prevent obvious garbage from reaching production tables. You need observability. How do you know it failed? Why did it fail? Why is it slow? And what changed since yesterday? If you learn this layer, you stop being someone who writes transformations and you become someone who owns pipelines. And that shift is what moves you into better roles and better compensation. Now let's address AI in 2026 without hype and without fear. AI doesn't remove the need for data engineers, it increases it. AI systems still need clean, governed data. They need reliable pipelines. They need access control. They need monitoring. You don't need to become an ML engineer to be valuable, but you should understand one key idea. AI is a new consumer of your data pipelines, and that makes governance and trust even more important. More unstructured data will enter pipelines, log text documents, and the quality expectations become higher because errors propagate into downstream decisions. So the roadmap doesn't turn you into an AI engineer, it upgrades your data engineering fundamentals to meet new consumers. Now let's make this roadmap practical with 0 to 6 month plan. In month 1 to 2, focus on SQL, daily, joins, aggregations, window functions, plus Python basics and Git. Build a simple project with a clear flow, pull data from an API, store raw, clean it, and produce a final table. In month 2 to 3, add Spark fundamentals, partitions, shuffle, joins, and writing Parquet with a basic partition strategy. Build a batch pipeline that outputs partition data and document it with a clear README so anyone can understand what you built and why. In month 4 to 5, commit to one track. If you're track A, go deeper into warehouse thinking and transformation patterns. If you're track B, go deeper into the Databricks stack, Delta concepts, governance basics, and scheduling mindset. If you're on track C, learn Kafka basics and streaming fundamentals like late data, checkpoints, and SLS. The goal here is end-to-end project that matches your target track, not 5 random tutorial projects. In month 6, you do the production upgrade, orchestration, reruns, and backfills, data quality checks, observability mindset, and performance habits. Your final portfolio project should look production style, incremental runs, safe reruns, basic tests, a partition strategy, and short notes about performance and cost trade-offs. If you can build that, interviews become dramatically easier because you can speak from proof, not from memorization. Let me also tell you what to skip in 2026 because skipping the wrong things is a superpower. Don't tool hop every week. Don't try to learn all clouds. Don't build a data lake that's just random packet folders without table management, governance, or maintenance. Don't ignore reruns and testing because that's where pipelines fail in real life. And don't ignore cost. A fast pipeline that costs 10 times is still a problem. Learn fundamentals, pick one stack, build one strong project, and expand from there. Now I will summarize this entire roadmap in 30 seconds. So the first, master the foundation, SQL, data modeling, Python, Scala basics, and Git or Linux. Second, think distributed in Spark. Focus on partitions, shuffle, and join, plus queue, and performance optimization techniques. Third, pick a track for 3 to 6 months, warehouse or Databricks or Lakehouse or streaming. So you stop wandering. Fourth, if you're on Databricks, focus on Spark and SQL, Delta concepts, Unity catalog, governance mindset, and jobs or workflows for orchestration. Fifth, add production skills, orchestration, read-ons or backfills, idempotency, data quality and observability. Sixth, treat AI as a new consumer of your data. So trust and governance matter more, not less. That's how you become job ready in 2026 without getting lost. So this is all for today. Thank you for watching. Do like, share, and comment your current level as a beginner or experienced, and also comment your track A, B, or C. Based on your comments, I will make the next videos in this roadmap series, like a SQL roadmap for data engineer interviews, a Spark performance roadmap, a Databricks track deep dive, and a streaming track roadmap. We'll meet in the next video. Till then, bye bye.